So hey guys, welcome back to my channel. Hope you are doing extremely well and you are excited for the lecture number 20 of the linked list series. Okay, so the lecture number 20 says we have to merge sort a linked list. We are going to discuss this question in the video. So I am pretty confident that all of you know about what is a sort and all of you know about what is a merge sort. All of you know about both these terms, right? So sort means sorting any data structure in the ascending order, right? And in the merge sort, we mean that we have to use a particular technique of merging two sorted arrays into a one. That means, suppose, let me give you a glimpse of merge sort. Suppose you have an array. Let us talk about the array first. That is 4, 2, 1, 3. The merge sort technique states that split it into half. That is, make two arrays out of it. 4, 2, 1, 3. And you will do this recursively. That is 4, comma 2 will change to 4 and 2. And similarly 1, comma 3 will change to 1 and 3. Right? Now the merge sort technique says you will stop your recursion. You will stop recursion if input length is greater less than equals to 1 is less than equals to 1, that is 0 or 1. So you can see all of the recursion will stop here. Why? Because 4 length is 1, 2 length is 1, 1 length 1, 3 length 1. Okay, now it says while returning back to your parent you will have to merge these. You will have to merge this in a sorted order. How? So you can see 2 is actually occurring before 4, so this will actually return, like this array will actually turn into 2 comma 4, right? Because we are merging them. Similarly 1 comma 3 will actually convert into 1 comma 3 because that is already sorted. Now 2, 4, 1, 3, if I sort them, if I merge them, I will see that 1 will occur first in the merging order, 2 will occur next, 3 will occur next, and 4 will occur next. And as you can see, the final call will actually get the answer as 1, 2, 3, 4, which is actually sorted. We will be using the same algorithm, that is, we will be recursively splitting into half and then merging while coming back to get the sorted, because the time complexity of such an algorithm is O of n log n. The time complexity of such an algorithm is O of n log n, right? So how will we do it? For the linked list? So 4, 2, 1, 3, 4, 2, 1, 3. So if I split first algorithm, let me give you a glimpse. If you are sitting in OA, right? You are sitting in an OA and you are not answering to your interviewer. If you are not able to code it down, no problem. It happens many of the times that you are not able to code a previously coded solution also. So what is the hack for doing it? You will create a vector of int answer. Let us say you will create an array, right? All the elements will be stored into the array. So 4, 2, 1, 3. The hack says sort the array. After sorting the array, something looks like 1, 2, 3, 4, right? Because we know to sort the array, we use a time of O of n log n, right? So that is not a problem right now. O of we will get the array as 1, 2, 3, 4. Now keep a temp here, and an I here, and then start traversing. That is 4 will change to 1, I moves here, temp moves here. 2 will change to 2, I moves here, temp will move here. 3 will I is here, 3 will remain, 1 will change to 3, I moves here, temp moves here, and 3 will change to 4. And now you will be able to see that 1, 2, 3, 4 will be your linked list without any confusion. You just use an array to get your answer, right? Now this is the hack. Don't do it in the front of the interview because things might not go the way you want. Okay, moving on. How will you do it for the linked list? Actually, the implementation of this algorithm on the array is actually more difficult than the implementation on the linked list. How? Let me tell you. Okay, so for the given linked list 4, 2, 1, 3. First step for your input will be to find middle. To find middle. Now this has already been discussed in a video and I have attached the link in the description. Make sure to watch it, right? To find the middle. So the middle for this will be mid. Remember, you will have to, in the cases of even, you will have to find the middle element which is occurring first. You can see that this is also middle, this is also middle. I want the first one. Okay, that is also easily possible. How? I will just use a slow and fast approach, and fast will move up until fast is not null, and fast next is not null, and fast next of next is not null. You just have to add this in the previous solution just you saw to get your mid actually here in the case of even nodes. For odd it will work fine, it will give me the like 1 2 3. For odd cases it will give me a mid here only, right? Okay, so how will I proceed? After getting the mid, I will create two linked lists out of it. I will create two linked lists out of it. That is, I will break this connection. I will keep a node B here and I will break this connection, right? So after keeping this node here and breaking this connection, the linked list something looks like this. That is, my head is here and my B is here. Now I will call the, suppose this function where I have got the input of the full linked list is known as f, right? If the function's name is f, I will call the f for this linked list separately and for this linked list separately. That is, after calling 4 comma 2, the 4 comma 2 will get into the function. That is, something like this is happening. 4 2 1 3 is actually calling two functions 1 and 2, which is 4 2 and similarly 1 3. Two functions are called, right? The functions is actually called recursively, so I will again find the mid and I will split it into 2 again, and it will actually go for 4 2 1 3. Similar to the merge sort on the array, my base case will be if my head is not null, if my head is null, sorry, or my heads next is null. Heads next is null, right? This will be my edge cases, this will be my base cases. So as you can see, one is achieved because heads next is null. So what I will be doing now is I will be returning it. I returned it 4, I returned it 2. Now after getting it, I will be using merge. Now which merge I will be using? So you can see my linked list was getting split into two parts. My linked list was getting split into two parts. So I will have to merge two. So have I actually done the problem of merge to sorted list? I have done the work of merge to sorted list, right? I have done the work of merge to sorted list. I will be using that only. I will be using that code only, right? So I will not explain how this works again because that had already been discussed in the video, and the link is in the description if you want to watch it. So if I use it, it will get convert into 2 to 4, and this linked list will now get converted to 2 to 4. Similarly, this linked list will now, this is actually the same, it will remain 1 comma 3 only. And now when I will be returning to the parent, that is 2 comma 4 and 1 comma 3, these two linked lists are getting returned, and if I merge them, it will actually get converted to 1 2 3 4, and which is my answer. I want it as an answer, right? 1 2 3 4 is my answer. 1 2 3 4 is my answer, right? So you are able to see that merge sort on the linked list is actually very easy as compared to the fear we have, right? So how will I do it? So suppose this is my driver function f, which is taking the head of the linked list, My first step is to define the base case. That is, if my head is equals to null, or my heads next is equals to null, right? In that case, simply return your head because you have reached the minimum possible length, right? Now I will find the middle. So mid equals to middle node, which is already done in a video of head. You got the head middle node. Now what you will do, you will say A equals to head, the first linked list, B equals to mid next. Now to separate these two linked lists, I will be breaking the node of mid. I will be breaking the connection between mid and next. That is, mid next equals to null. Now these two linked lists, that is A and B, are actually very separate. Now I will call the function recursively for A and B separately. That is, f of A is equals to f of A, B is equals to f of B, right? The f of A will actually return the sorted linked list of A into A and sorted linked list of B into B. After that, merge, like head will be equals to merge to sorted list A comma B, right? And now you can actually return your head safely. Now this code will run absolutely fine. The algorithm has been discussed here, that is 4213 4213 4213, and that will be returning to the parent as well. So I am able to understand that you have actually got the idea of how to do it, how to proceed with it, right? And it's time for you to see the code, right? And let us then end the video. Alright, so here is the coding section. I am using the lead code coding section to write the code, and as you can see, I've already pasted the code for middle node as well as the merge to list code for the useful purposes. And you can see I've just added fast of next to next to get the in the case of even node, I want to get the first node, not the last node. Okay. So now starting with it, first my base case is if my head is equals to null or my head next is equals to null. In that case, return your head, return the head. Otherwise, first get the middle. So list node star mid equals to middle node using the head, middle node using the head. After that, your A will be head and your B will be mid next. B equals to mid of next. After that, just break the connection between the first and the second linked list, that is mid next equals to null. Now A and B are actually representing two separate linked lists. I will just call the recursion function for A and B separately. So A equals to sort list A, B equals to sort list B, and now I will just merge them. That is head equals to merge two lists. One name is A and other name is B, and now just return your head, return the head, and it should run fine. Let us try to compile and run it. Hope it will work fine. In the meantime, do consider subscribing, and is running fine for the simple test cases. Let us try it for the submission also. It is running fine. Okay, thank you for watching, and we meet again in the new lecture. Till then, stay tuned and have a nice day. Thank you.